Could be. All the angles are different. That could be. Could be. Not necessarily.
Maybe
two of the angles are different. One of them is the same.
Oh, that's what? Two of the angles are the same. One's different. We have a name for that.
What is it?
equilateral.
Isosceles triangles. Two angles are the same. The other's different. What about when all three angles are the same? That's called
Equilateral.
scalene. Would mean all sides are different, which would mean all angles are different. But this one normally talks more about the sides instead of the angles. Those are angles.
What is an oblique?
Well, those could also be sides. So those are all kind of sides.
Maybe.
Okay, so an oblique triangle, I'm going to give you the first word of the definition.
No.
It's not
A right triangle.
not a right triangle. So an oblique triangle is any triangle that's not a right triangle. We used to call them acute and obtuse. But instead of saying acute triangles and acute triangles, obtuse, acute, we just call them oblique. Cool. So because we're kind of limited for time, I'm supposed to show you where our formulas come from. Later, maybe. The law of sines. Does that look somewhat familiar? Sine alpha over A, sine beta over B, sine, I can never remember. I think that's lambda. Sine upside down Y over, no, it's right side up Y. You know what? Never mind. I think lambda's this way. See, I don't ever remember. Remind me to look this up. All right, so here's what's really important. If this is angle alpha, opposite angle alpha has to be side A. Opposite angle beta has to be side B. And opposite angle whatever has to be side C. All right, well, let's just call it angle C inside C, even though it's definitely not C.
Is that supposed to be gamma?
Maybe. Did you look them up?
No, I was just wondering.
It could be. I have no idea.
Gamma, the third one in the alphabet.
Yes, alpha, beta, gamma, delta. So probably is gamma. This left triangle. What would angle beta have to be here? Well, if I know this is 98 and that's 43, that adds to be 141, which means this has to be 39, because they have to add to be 180. Is everybody okay with that? Now we would say sine of the angle over the side opposite equals, I can pick either of the other angles to solve for. Let's just go ahead and do sine of 98 over, what's the side opposite 98? And so do you see how we could solve this to find side A? Cross multiply. So this leaves me with sine of 39 times A equals 22 times sine of 98. And then I would need to divide by sine of 39. So A equals this. And we just have to type that in, right, to find the angle.
Did we get 9?
9. That's A.
Oh.
A. We did not get a 9. Sorry. Everybody on board there? And so that's very straightforward. All right. If I look at the second triangle, which was the case angle, angle, side, what would have to happen here? Well, I know the missing angle is 100, but I know an angle and the side opposite. That means I can use the law of sines. Sine of the angle over 5 equals sine of 100 over, and we didn't name these. Let me just name this one B. Let's call this one C. And see how this is very similar in the process. It's going to be cross multiply. It's going to be divide by sine 50. And whatever I get will give me the first side. Now, how can I find the last side? I'd have to do this again, right? Just do the law of sines again with a sine 30 over c as my other ratio. And again, we'll talk about that later. But you see how those are similar. All right, if I had side-side angle, let me look at the notes. Does it, they don't draw me out a triangle anywhere, do they? No. Okay. So here's the situation with side-side angle. I know a side, I know another side, and then I know the angle. So let's say this angle is 20. See how this is side-side angle. Can I easily find all three angles this way?
Yes.
Not like I could before. You know, before I knew two of them. How did I find the third one? Add up and subtract from 180. And I could easily find the missing third angle. But there's no easy way to find either of these angles without setting up the law of sines. But I do have an angle and the side opposite, which means I can use the law of sines anytime I have that relationship. So if I set this up, sine of 20 over 3, I'm just going to name this one alpha. I'm going to name this one beta, and this can be b. So sine 20 over 3 equals, I have to use angle alpha, right? Because that's the only other piece of information I know is 7. So I could say sine of alpha over 7. You see how this one is a slightly different proportion. It's not going to be so easy to solve. It's close, but it requires one extra step. So let's go through what has to happen to solve this. I would still cross multiply. 3 times sine of alpha equals 7 times sine of 20. All right, remember, I'm trying to get alpha by itself. Well, alpha is being multiplied by 3 first. So divide by 3. Does that get alpha by itself? No. Why is the alpha not by itself? Because we're taking sine of alpha. How can I get rid of taking sine of an angle? Inverse sine. And so because we take an inverse sine, that introduces all kinds of extra funny business that could happen. Does anybody have a calculator? I don't know what this would be. Let me do it. Mode degree, good. 7 sine 20 divided by 3. And then I would do the inverse sine of that. All right, when I did this, I got 52.9 degrees. Can somebody else back me up with that? But type that in. So what y'all got? 52.9 degrees. This is a possible solution. Notice I didn't use the article adjective the. I used a. Which means there could be another solution. If you did the inverse sine and you got a math error, then that means there would be no solution. And that happens sometimes. So this one is not no solution because we found a solution. But it's not necessarily the solution. Because it could be a second. Here's how you find out if there's one solution or two solutions.
Why did we divide by 3 and not 7?
We're trying to get alpha isolated.
So we just get to choose what we divide by.
No. What's on the same side as alpha? The 3, so you divide by 3. If 3x equals 9, you don't get to choose if you divide by 3 or 9.
No, you get to divide by 3.
Whichever one's on the same side as the variable. What's on the same side as the variable?
3.
Go with me. This is not my strong suit. I'm trying to draw this. But see if you can visualize this with me. Okay. I'm going to draw this. I got to be legit. I need my angle. I don't have an angle. Alright, we'll just go with it. Okay. So say we know this side is 3. We know no. Let me draw it this way. I gotta draw my longest side first. Longest known side. So this is 7. Okay. And then 20-degree angle. I'm just gonna guess this one. I can get close enough. This is 3. Oh, my brain. It's not brain. My brain's not braining. Something I'm screwing up. Okay, here it is. I got it. Okay. I think. This is 3. Okay. This was opposite 3 is 20. Is that right? This is 3. I have a side of 7. That's not great. Okay. But pretend like this is my side of 7. I don't know why I'm using this. Just because it swings, I guess. Here. Okay. This is just way off the road. My side of 7 No. Wait. Stop. It's still not working. I'm missing something. Oh! Okay, there's my side of 7. Okay, here we go. Now, imagine my side of 3. Where could I put my side of 3 along this line that would then make a triangle? Well, I could go here. That would make a triangle. And think about the ramifications of that. I know, what's the other thing I know? I know opposite 3, I know this is 20. That's still 20. Which of these sides is the longest?
So,
It looks like that side's the longest in this scenario. But that's not the only place I could have drawn my side length of 3. If this was 7 and this was 20, I could have drawn my side of 3 here. Which would then make what my longest side?
7.
And there are 2 possible cases because this side, the short side of 3, I don't know which way it should go because I don't have enough information to make that determination. Now, what we did just find out was we found alpha to be 52.9. Well, think about what would happen if this was the case. If alpha was 52.9, what would beta be? Well, it would be 20 plus 52.9 is 72.9. 180 minus 73 is 107.1. So in this case, beta ends up being my biggest angle, which represents this case, right? Here, alpha was 52.9. This was 107.1. It's obtuse, and it's across from my biggest side.
That's the biggest angle.
Right. Or alpha could be the obtuse angle. Right here, this was alpha. And this was a possibility, but it's not 52.9. Because we took an inverse sine. Inverse sine is defined for quadrants 1 and 4. Because my ratio was positive, it spit me out an angle in quadrant 1. But what we just learned about last unit was that that's not the only possible positive ratio that exists. There could also be a positive ratio in quadrant 2 because sine is positive there. So what would have to happen to give me a reference angle of 52.9 in the second quadrant? That means I've rotated 127.1. Which means even though I took the inverse sine of alpha and it gave me 52.9, this could have been a reference angle to the second quadrant, which was 127.1 with my rotation. Which means this alpha could be 127.1. Could this triangle still make sense? 127.1, that's 147.1. Could I still find a third angle?
Yes.
147.1, 33, 32.9. This is 52, right? Yeah, 52. And so when this happens, you're going to have 2 solutions. I'm going to have to solve out everything for this triangle and solve out everything for this triangle. I'm trying to explain how it's possible. Right? That's my goal right here. Not necessarily you understanding all the steps. When we go through the steps, we'll make it very algorithmic, where you just are checking boxes. But here's the why it could happen. But it doesn't always happen. It just sometimes happens. Okay, that sucked. cases. But anyways, let's go through this. So here, I know some stuff about my triangle. So I'm just going to draw a generic triangle. Now, which of these is angle alpha? It really doesn't matter. Okay? I normally start bottom left. Whatever you feel good about. But if I make this alpha, this has to be, what does this have to be? Side A. Opposite angle alpha is always side A. So this is my A, but it tells me A is 120. Okay? Now just pick another side. It doesn't matter. It's 121. And now this is side B. But if this is side B, this must be angle beta, which means the ones left are gamma. I did it backwards. Just draw Y, Cody. It's in your name. There we go. Y and C. It's not a Y, it's a gamma. Whatever. So if you want to think about it like Northeast talks about, this is what? This is angle, side, side. Or they don't want to go that way because it's a bad word. Side, side, angle. Okay? This is the one that there could be two cases. Or there could be one case. Or there could be none. No solution. I wouldn't know that until I just started setting this up. Do I have an angle and a side opposite? I can use the law of sines. Sine of 80 over 120 has to equal, well, the only thing I know, this is side 121, and I'm looking for sine of beta. For me, at this point, I know there could be two cases. Because I can solve this through and see, I'm going to do inverse sine to get beta by itself. So there could be two cases. So let's just go ahead and solve it. I've got 120 sine beta equals 121 sine of 80. I divide by 120. That tells me sine of beta equals 121 sine 80 over 120. Take an inverse sine of both sides. So make sure your calculator is in degrees. You're going to type that out. Inverse sine of fraction 121 sine 80. I don't think I checked it in degrees. I didn't. I said it. I didn't do it. 121 sine 80 over 120. I got 83.2. Anybody have problems with that? But because I did an inverse sine,
So you just do
inverse sine of this garbage all at once. I just typed that all in at once. And I got 83.2. So this could be 83.2. Huh? It's a solution. Now, could there be a different solution? Well, let's just think through. What would give me an 83.2 degree angle in the second quadrant? How much of a rotation is that?
That would give us
96.8.
So
Is
there's
everybody good with that? 96.8?
There's two possible solutions.
Maybe.
Because that works.
Does it?
Yeah, it leaves you with like 3.2 for the other angles.
So this could be 96.8 for beta, 121, 80, 120. Here's how you know. Can I find a third angle?
It's got to be the 83 one.
Can I find a third angle here?
Yes.
96.8 plus 80 is 176.8, which means this could be an angle of 3.2. It exists. This one has two solutions. Because
I
that
know which-
angle exists.
I know which one's right.
They both are correct. They both could exist. The drawing was not to scale. I just made this drawing up. Right? I didn't know anything other than what was given to me. And I just happened to draw this.
I know, but like,
They both are correct.
the 83 one's better than.
How are you going to know if there's not two cases? Well, what if this was like 140?
It wouldn't exist.
Can't exist. Because then I go over 180. And there's no way I can find a third angle. That's how you know it's one solution. Okay? That's how you can check every time. So, this one stinks because it's the most work. All right, so what do I know so far? I know, let's just solve this triangle out. I know two angles. Can I find the third angle? Yes, that's 163.
16.8.
Everybody good with how we found that side or that angle? And now then I'm going to have to use sine of 16.8 over c. Now which of these should I use? Here's my teaching point. Do I know an angle and the side opposite? I know this angle, I know a side opposite. I know this angle, I know a side opposite. Does it matter which one you use?
No.
Technically, no. But as we practice, you should pick one of these over the other one. Every time.
180.
One given.
The one given. You should always pick the one given. I found this. If I screwed up, then I might be able to catch it if I keep using the sides given. Side and angle given. Okay? So don't ever use the one you found unless you absolutely have to. And here I don't have to. That's also a good reason, right? Not another decimal. But now if they give me a decimal, I'm still going to use it, right? That's my secondary reason. Sine 80 times c equals 120. Sine of 16.8. Divide by sine 80. So whatever I get when I type this in. 120.
You don't have to do inverse sine, do you? 'Cause
I don't.
You're finding the angle.
That's
not
right.
the side. You only do inverse sine when you're finding the side, right?
You take inverse sine of sides to give an angle. Inverse sine gives an angle answer.
Wait, no. You find inverse sine when you're finding the angle, not a sine.
Inverse sine finds an angle. When I did inverse sine earlier, it gave me this angle. I got 35.2. Which means side C would be 35.2. And I saw this is my first solution. All right? This solution 1.
Houston
I
teachers
fill
will
out-
have report cards ready for grade
I
7.
fill out
grade
all
12,
the
and
missing
you'll place
parts
them the
on
student to the
my
hospital
open
office
map.
to get your
There'll
report
be-
cards to hand out this period.
They'll ask me what is side
Grades 7
C,
through 12, place
what's
them the
angle
student
C-
to the
what's angle
office to get
gamma,
your report cards.
what's
Thank
angle
you.
beta. And I would type them all in. Here's a way, just kind of a quick, this does not guarantee you got the answer correct, but it means it could be correct. I always go through this. What's my smallest angle?
16.8.
What's my smallest side?
31.
The one opposite. That's good. What's my middle angle?
80.
What's my middle side? Good. Largest angle? Good. So this could be valid. If one of those does not match up with biggest, smallest, then you know you're wrong. Okay? Just because it does match doesn't guarantee you're right, but you should feel better about it. Okay? And that's a quick check. Now, I've got to find the second solution. This was just a solution. So let's clear the boards. And now I've got this little triangle. So now the only thing left to find here would be this side C. Right? So we could say sine of 3.2 over C equals, Which one am I going to use?
80 over 120.
Absolutely. Sine of 80 over 120. Is it okay if I don't write the algebra out? Because I'm kind of getting scrapped for space. Can y'all go through the process here?
You just gotta hit a little squiggly split.
It's going to be 120 sine of 3.2 over sine of 80. Everybody's okay with that? I just cross multiplied, isolated.
all over.
I found C to be 6.8. And again, that makes sense. Could be a solution. And it really makes sense because this angle is so small, and now this side is very small in comparison to the other. So, this would be my second set of solutions. This is my beta. What else did I find? This is my gamma. This is my side C.
Wait, isn't cosine in the fourth quadrant? One in
I think I really like the lots of those things.
Yeah, they were good.
So we gotta do it in inverse. Yay.
I cannot draw Y. This is the scariest. The lambdas got me all jacked up. Like my brain is not.
What?
Me want to call it a lambda, but it's a gamma. I'm trying to draw lambdas. And lambdas, I know to draw like this. And now that I try to do my Y's and I do it, I get it backwards. My brain's not braining, is my point. It all is because I couldn't draw this stupid situation earlier. It ruined me. I knew the makings of it, but I couldn't set it up.
Okay. So we got 5.7.
That's the other one that I didn't work.
So, do we do the inverse sine of 10?
Here's your report cards.
Oh, thanks. Wesley was just going to get them. That's a student for no reason. 10 sine 80. They have no patience in office.
10, 7, 80.
Over 100? Is that what y'all got?
Yeah, yo.
And I got 5.6.
No, oh, I got the radian plus A plus BI.
It's a 5.7.
Are we supposed to be in degree mode or?
It should be in degrees.
Definitely degree mode.
Aren't you doing degrees?
Yes. Wait, does the A plus BI, does that matter?
A little bit late to get the report card.
Yeah, they dropped them. Just like 2 seconds ago. So this was a possibility. What was the other possibility? I could get this reference angle in the second quadrant,
Yeah.
which would be an angle of 184.3.
No.
Could there be an angle of 184.3 here, knowing that this angle is not 184, 174. Sorry. Call me out. Y'all always give me the dumb look.
So no.
174.3 and 80, that's over 180. So this is a one solution case.
Yes.
Is everybody okay with that?
Okay.
And so now then you just have to do law of sines one more time. So this means my missing angle would have to be 94.3. Is that right?
So this is finding. Wait, inverse sine finds angles. So C
Yeah,
is 5.
But again, I'm just following the algebra. Right? Like I don't think about it that way. I was just isolating beta. Can I just show you that process?
Oh, so you're finding the one you don't have.
Well, yeah. So like right here, when I started, here was my angle and my side opposite. I had to use that one. The only other thing I knew was 10.
Yeah, and 10 can only give you a 10.
So I just set it up. I had to show you like, but then once I tried to get beta by itself, I had to take an inverse sine.
I feel like this one's easier than the last one.
It is. I mean, it is. These problems are. Now the next ones get off the rails, but we'll get there. When we get there.
Great.
And you should have seen this before, which is good.
Yeah,
What we got? Sine of
I don't really mess.
80 over 100 equals sine of 94.3 over C. So it should be C equals 100 sine of 94.3 over sine of 80.
Exactly what I did, and I got -7.
Probably in radians.
I'm in degrees.
Double check it.
Did you give it?
So do
100
times sine
sine 94.3.
all over sine 80. You should have done it. You really should.
101.3.
Yeah, 101.3.
100 sine
94.3 over sine 80.
But I was just trying to show the radio.
I did it at first. I think I might have did it over 80 instead of over sine.
Did I kind of redeem myself after that horrible start?
Yeah.
You kind of understand? Did at least? That was awful. I apologize. It took me way too long. Yeah, I'll put it back together. See, I wanted this because I wanted to prove that this side 3 could swing and still become true.
Couldn't put Humpty Dumpty back together.
Yeah, no, that's what I gotta do.
He sat on a wall, and then he had to go forward. What if instead of Humpty Dumpty falling off the great wall, he just had a locate
I've had great falls. This is my second one of these I've ever had to work. Remember, if you're gonna make up the 3/8 test sometime.
Maybe I'll get some. Wait, where's the cards at? Yeah, those cards at.
Oh, yeah, I don't know. I moved them. Hey, report cards. Make those people come back. Well, that's fine. Just remind them I have it if they want them.
I'm gonna burn my
Jackson. Alex, Alorza, Macy, Gabriel, Colin, Owen, Cam, Taylor, Grayson, who's that one? Sandler, Austin, Jay, Jonathan, Julia.
This is Owen's.
Oh, is that not yours?
No. I think you put mine right there.
Sorry, I thought that you maybe weren't in here when I looked up.
Is that better? Well, hey, Easy Bridge.
Today is Easy Bridge.
We're doing that today. It's easy.
It should be my biggest side, so it should be over 100. 100. 0.26, so 0.3. 101.3. Somebody else get that? Here we go. I've got A is 10, B is 4, beta is 50. So this is 10. Opposite 10 is alpha. I don't know alpha. This is 4. Opposite 4 would be beta. That's 50. I don't know C. I don't know gamma. Can I find the third angle very quickly? Just by looking up there? No, because I don't know the second angle. So this is one. When I only know one angle, I could have multiple cases. I'm known of that going in. Can I use the law of sines? How do I know I can use the law of sines? I've got an angle and a side opposite. I have a pair, so I can do the law of sines. So sine of the angle over the side equals, the only other thing I know is 10. So sine of alpha over 10. Cross multiply 4 sine alpha equals 10 sine 50. Divide by 4 and then take an inverse sine of both sides. So alpha equals the inverse sine of 10 sine 50 over 4. Did you put it into Greek? Oh. So this triangle can't exist.
So it just doesn't.
So this would just be no solution. This would be your favorite case whenever you get the error. Because that's it. You're done. So what they're saying is, we know this angle is set at 50. So from the horizontal up 50. And we know this side is 10. So like we know the highest point here. What that means is this side of 4, if I were to swing it, it would never reach this line. It's too short. So I can't make a triangle with it. It has to be something more than 4. And we could really set that up with tools if we wanted to. We could really get a ruler. We could really get that, what's it called? Protractor. Is that what tells you the angle? But this isn't geometry class. You talk to me. How do you find the area of a triangle? Area equals 1/2 times the base times the height. That's great. That's a great formula. When's that going to work? Does that work for every triangle? Is it?
Yeah, it works for every triangle.
Every triangle?
Yeah.
So if I had this triangle here, this was 3, 4, 6. What's the base? 4, sure. What's the height?
You don't have the height.
I don't know the height. Right? Does that not stink? You don't know the height. And you got to do the...
So if you had the height, it would work.
Yeah, it would if I did, but I don't. I don't have the height. So I'm just going to drop a height, do this. And we could do trig to find that height. Do you believe me that we could do trig to find the height?
Yes.
Well, we could find this angle. And if I know this angle, now I've got a right triangle. This is opposite. I know the hypotenuse. The adjacent sum torsion of... Anyways, trig can make me find it. That's what this is saying. But there's actually a formula that will always work. That I don't have to do the trig every time. The area is 1/2 times the base times the height. But it's not necessarily the base and the height, it's just any two sides. 1/2 times any two sides times sine of the angle between those two sides. 1/2 times two sides times sine of the angle between those two sides. Well, why have you never seen that formula before?
Because we always use this for a special case.
It is. So think about, you needed right triangles, right, to find the base and the height. Well, think about this. If the base was 4 and the height was 3, and you had to find the area of this triangle, you could do 1/2 times the base, 4, times the height, 3, times sine of the angle between them. What's the angle between them? 90. What's sine of 90? 1. Multiplying by 1 did nothing. So we didn't show you because it didn't matter. But it's always been there. Just was a 1 that was useless. But now you're old enough to know the truth. I'm just kidding. Don't go that route. So if I look at the first example, I've got a triangle. And it wants me to find the area of that triangle. Well, I'm going to draw it to set it up. You probably don't have to draw it, but it just makes me feel better when I draw it. This is beta, 42. Opposite beta is B. I don't know it. This is A, 7.2. So this is alpha, which means this is 3.4. This is gamma. Do I know two sides and the angle between them? Side, angle, side. Then I can find the area. 1/2 times the side times the other side times the angle between them. Again, I could go through the trig and show you how that works, but I don't think anybody cares. So I normally am all about that, but eventually I get to where I know the class doesn't really care, and I just put it up there. What do we get? 8.19 square feet. Do I have a second person that got that? Okay. I've not done these yet, so I need some reassurance. All right, we look at this. I know two sides. I'm looking for the angle between them. Okay? Could I use the law of sines here? Do you know an angle and the side opposite? So I can't use the law of sines to find that angle. But knowing the area is interesting because I could use that area formula. Area equals 1/2 side, so A times B times sine of the angle between them. So for us here, what's my area? 226.89 equals 1/2. What's my side A? Pick one. What's my side B? Pick one. What's the angle between them? That's what I'm looking for. Theta. You see, I just plugged into the formula. This formula has 4 unknowns, but I know 3 of them. So guess what I can do? When I know 3 of the 4 unknowns, I can solve for the one I don't know. Do a little algebra. So if it were me, I would probably multiply that ugly number first. So 1/2 times 26 times 36. 13 times 36, that's 360. And 108, 468. Double check, thank you. And so that would be 226.89 equals 468 sine theta. I have to challenge myself sometimes. Keep my mental math sharp. Keep it sharp. Divide by 468. And so I'm left with sine of theta equals that garbage. I don't care what that is. And how could I find theta? Take an inverse sine of both sides. So if you do the inverse sine of the garbage, you know what I mean by garbage? This is the garbage. 226.89 over 468. Anybody get an answer for me? What'd you get? I don't know what it is.
At the end, it's just 29.
28.999, 29, all have it. Okay. A communications tower is located at the top of a steep hill, as shown. The angle of inclination of the hill is 75 degrees. You see that here. A guy wire is to be attached to the top of the tower and to the ground. Y'all know what a guy wire is? It's called a guy wire. It's not a guide wire, but it's probably what you call like that that's got the yellow outside the front window that connects to the power line pole. That's a guy wire. So there's a guy wire from the top to the ground. That's what this is. 154 yards downhill from the base of the tower. That's what they have drawn here. The angle formed by the guy wire is 11 degrees here. Find the length of the cable required for the guy wire. So we're looking for that dotted line. I'm trying to remember. we've got to find this dash line. Okay. So there's a couple of different ways you can do this. Let me try my best. Drawing is not my strong suit. I'm just going to imagine this. I know they drew our tower kind of funny with like two sides like a radio tower really would be, but I'm just going to imagine it as one line here. So there's my tower. Okay, and then I have my line here that will continue up here. And if I were to continue this tower here, okay? So I'm just continuing lines. Okay. If I were to draw another line parallel to the ground, right? So here's the ground. I'm going to draw another one parallel to the ground right through that axis.
What is this? This is
Yeah, thanks. Now I have two parallel lines cut by a transversal. Welcome to geometry. Okay? Two parallel lines cut by a transversal. So same side interior angles are supplementary. Alternate interior angles are congruent. Remember all that junk? All right? What I have here is I have two angles that are, what's the word? The word's not even in my head. Corresponding. They're in the same position of their transversals. This is the top right of these four, and this one is the top right of these four. We would ignore the blue line, right? The blue line is not part of my parallel line. It is not part of my transversal. So the blue line is out. So corresponding, sorry, do you have a question before I? Corresponding angles are congruent, which means this angle is 75.
I mean, I guess that helps. So, now we know the rest of it's 105.
So now, let me get this straight in my head.
You know that this is 90.
Give me 1 second. Just give me 1 second. So, again, I probably shouldn't have drawn this blue line yet because I can't really use it because it's not a parallel line. It's not part of my transversal. Okay? So just ignoring that is going to make it easier for me to see what we're looking at here. Okay?
Go ahead and delete that.
So if that angle is 75, then I also know this angle is 75 because those are vertical angles. And vertical angles are congruent. Okay? Which means pick a different color. From here to here would be 105. And from here to here would be 105. Everybody okay with what I've got drawn? My 360, my vertical angles. Now, if I reintroduce the radio tower, I can now see, again, drawing is not my strong suit, so we'll clean it up here in a second. I can now see that while this whole thing was 105, right here I have a right angle, which makes this portion 90.
That's what I said earlier.
Gotcha. It just gets confusing to me if I don't break it apart. This looks awful. I get it. Which means this part is 15. All right, is everybody on board with me? So, what really matters is the guy wire triangle. Right?
And we,
I'm really looking for, I don't know why I drew a right angle there. Give me 1 second.
We have a right angle on the guy wire triangle.
We don't.
Oh,
Then what,
I thought we,
what's the 90?
yeah. I thought that was on.
That is from, the 90-degree angle is from this that was parallel to the ground with the guy wire.
Okay.
But remember there's this part.
Oh.
It's 75. So, if I just redraw this triangle, right, that's all I've done here. I'm going to redraw it and clean it up. Because, again, that's a disaster.
Wait.
I am looking for the guy wire length. I'm going to call it C. We know that this angle is 11 because they told me it was. We know that this side was 154 because they told me it was. I now also know this angle. That goes from the radio tower to the ground. What would that angle be? Well, this portion is 90. This portion is 75. Which means that whole angle is 165. Huh?
I thought it would be 90 plus 11 because the.
Where are you seeing 11? 11 is here.
Oh, that's one of the angles.
I'm looking at this. This is my triangle.
Yeah.
Yes, 11 is this one.
90 and 75 is the big angle.
That's correct.
Okay.
From the ground to the tower.
So 165, 11, and then 4.
So now I can find the third angle. Is 4. So, did y'all, I'm going to erase my garbage in the middle, okay? But did you see where I got that from? Now, when we work these problems going forward, do you see an easy way that you might could figure out what this angle would be right here? For this triangle. Well, this is 165. How do you think we can get that 165 a little more easily next time?
154 plus 11.
No, that is a wild coincidence, but that is not the way we're going to get it. I appreciate that because I did not see that coming.
154 is the side.
It is, I know, but this angle is always going to be 90 plus every time. So going forward, when you have these on your homework questions, if you don't want to draw the whole situation, it's going to be 90 plus this for that. Okay? Yeah, I wouldn't either.
If I saw that on the test, I'm taking that L. Like, I'm just taking that L.
But now, do I know an angle and the side opposite? 4 and 154. So I can use the law of sines.
This is going to be a huge triangle.
Sine of 4 over 154 equals sine of 165 over C. Cross multiply. C times sine of 4 equals 154 sine of 165 divide by sine of 4. So C equals, you can just type that in, but I'm really hoping you get that number. What time does that take? Oh my gosh, that's a hurry. Is that it?
Yeah.
Yeah. So we'll go 390 if we're going to 3 decimal places. Sorry, I hit the wrong button. Never going to use this in real life. Well, here's a real life example. They're trying to find the distance across a pond from point A to point B. Well, they can't just measure it. They ain't got a ruler and then go get out there and measure. So what they did was they went and found a point here and measured the distance from this point to these points. And so you get the whole situation here set up. What we want to know is the distance from A to B.
I got error. Wait.
What do I know? I know a single angle. But do I know the side opposite? So what could I do? I could do the law of sines. So you do this, sine of this over this equals sine of this angle over 400. I solved that out. I'm going to then know this angle. That's nice. But is that what I want? No, I want this distance. But once I know this angle, what can I know? Well, I know two angles, so I can find the third angle. Once I know the third angle, I do the law of sines again. Right? So it's almost like the completing the triangle problems that we did at the beginning. Right? It's just got a word problem with it. Just in case you ever want to go be a navigator. So they talk about getting your bearings. When we describe direction of travel with respect to the cardinal directions, north, south, east, or west, often a concept called a bearing is used. An object's bearing is its angle formed clockwise from the north. So in trig, this starts as your 0, right? And then we rotate counterclockwise, 90, 180. Well, in this whole bearing situation, due north is 0. It's almost like a clock, right? 12 o'clock's the beginning. And then we rotate clockwise with 90, 180, 270. This, there may be like 2 questions that use this on the My Open Math. So it's not that big of a deal. It's pretty easy as long as you know where you start and which way you're going. So for example, can you draw a picture of an object traveling at a bearing of 115 degrees? So where would 115 degrees be?
Second quadrant.
It's not in the second quadrant. That's what I just got done telling you. Normally it would be in the second quadrant. But when we're talking about bearings, remember we start here at 0 and we rotate clockwise. So this is 90. This would then be 115. So 115 degrees will be here. Yes, it's just like the Fortnite. Yes, it's a clock. Yes, it's anything besides trig. This is how it normally goes.
Yeah, I
Okay.
thought we were talking about trig.
Can you draw 315?
Yes.
Where would 315 put you?
Or first quadrant.
Oh my gosh, Lord help me. It's the second quadrant.
Oh, yeah.
This is 0, 90, 180, 270. So 270 and 45 more puts me at 315.
This time I just started at
Yeah, I don't even care anymore.
and went clockwise.
Well, we're out of examples, so hopefully you got it now in those two.
I've got it.
That to me that's not as important because if they ask you something like this, that's all they're going to ask you is that, and it's over. Okay? Here, you're going to have to start using this. This is another way to express it. That is the way that your hard problems, your Sasquatch problems are going to be written. Like this.
Sasquatch.
No, yeah, that's what we're fixing to get to. So, this is read as 30 degrees east of north. you are 30 degrees east of north. So, let's talk about that. What does 30 degrees east of north mean?
120 degrees.
No, stop. Just stop. Just stop. Stop. Please stop. This is north. I'm having to go east of north. East of north. East is to the right, which means I'm going to go here. If I went 30 degrees east of north, this was north, here. So I had to rotate 30 degrees east of north. No, don't even think that way. If you were thinking rotation, we've rotated 60 from our normal. Because this 30 does not go to the axis. This 30 draws to the y-axis. Because you just have to draw however it tells me. East of north means I'm drawing back to north.
No, but we started.
We started north, we drew here, and we drew back to the north. 30 degrees east of north. Every time. So when you look at the next one, it says 45 degrees. That's an easy one, stupid. 45, I'm talking to myself. I'm not calling anybody stupid in here. I'm saying that's stupid that they have 45. 45 west of south. So if we went south, we would be here. But now we are 45 west of south. West would be this direction, which means this is 45. I call this one stupid because what's this one? It's also 45. It's a dumb one because you could have screwed up and put your 45 here and been okay. Here we go. 30 degrees north of west. So we're starting due west, which is here. And I want to go 30 north. Means I'm heading this direction, which means where's my 30 go? We go back to the west.
I've got the hang of it.
30 degrees north of west. Do we need more practice with these? Oh my gosh. The Sasquatch nest. Here we go.
Oh my God.
Probably all year, if anybody asked me what's the hardest questions we have in 113, I would have said it's these Sasquatch problems. I texted Mr. Kemp last year because it was the first year they ever done these. Like, we've done law of signs, but when they switched to My Open Math, they got these kinds of problems. And I said, these are crazy hard. He said, yeah, it takes a minute to get the hang of it. Okay, so here we go. Carl spies a potential. So that's just so we know. It's not necessarily the Sasquatch nest, but could be. Bearing 12 degrees east of north. Okay, let's draw this. Here's Carl. He's right here. Here's his orientation. 12 degrees east of north. He spies Sasquatch nest. Sasquatch nest. Everybody okay?
Yes.
What do I know? 12 degrees east of north. That means that this angle is 12. Can y'all see that color? Let's change it. Okay. He radios Jeff. Jeff is 52 degrees east of north from Carl. So somewhere over here, 52 degrees east of north is going to be farther to the right. Right? He's somewhere over here. Let me draw that again. Out here is Jeff. And he is 52 degrees east of north. So I went back to the north again. Everybody's on board. From Jeff's position. So now we're going from here. The nest. So we're looking at the Sasquatch nest. It's a bearing of 69 degrees west of south. So if I went to the Sasquatch nest, it's 69 degrees west of south. West of south. Which means this angle here is 69. Because that's west of south. Right, you're back to the south. You're back to the south. If Jeff and Carl are 510 feet apart, so where would that go? My orange line. Right, that's the distance from Jeff to Carl. How far is Jeff from the Sasquatch nest? So I'm looking for the purple line. Do you see my triangle that's formed?
Yeah.
Right? Do I know any of the angles in that triangle? Not yet, but I can find them.
12 plus 52. Or no, just 52. 52 minus 12. Yeah.
52 minus 12 would give me this angle.
Yes.
Right? This angle right here has to complete to be 52. Which means this angle has to be 40. Is everybody okay with that?
Yes.
Stay with me.
So is that alpha?
Stay with me. I need to draw it on my iPad because my next period isn't going to be here. So give me a second.
Yeah. Wait, do we
Look
know
at-
that 69?
Hold on. Shh. I've got two parallel lines that are both north, cut by a transversal, which means if this angle is 52, alternate interior angle, this angle has to be 52.
So, this
Which means this angle
is 69.
was 69. So this little angle would be 69 minus 52, which is 17. So now I can find the third angle of my triangle, right? Bring it back here to the triangle. I know 40, I know 17, that's 57, which means this has to be 123.
This is
Now I know an angle in the side opposite. Law of sines. So I can go sine of 120, dang it, Siri. Sine of 123 over 510 equals sine of, I'm looking for the purple side here. So the angle opposite would be 40. Sine of 40 over, I'm just going to leave it as question mark, since I made it a question mark before. I could have made it X, could have made it whatever. And I'm going to trust you guys can go from there to solve for the question mark.